In our study of physics motion fundamentals, we've already looked at distance and displacement, and then we've looked at how distance and displacement change over time, and we call those speed and velocity. And then now I'm wondering if there's another way that we can talk about how speed and velocity change over time. And we kind of have maybe an inkling of where this is going, because we've all likely driven in some sort of transportation vehicle at some point, and we know that speed changes over time as well. Okay, and when we talk about that quantity, we get acceleration. Okay, so really acceleration is change in speed or change in velocity over change in time. Now, there's kind of two different perspectives though. So velocity over time is, or change in velocity over change in time is average acceleration, and this would be a vector quantity because velocity is a vector. Okay, and at the same time though, if we have speed over time, we also call that acceleration, but this is a scalar quantity, right? So this is a magnitude only. So what do we use? Which one do we use? And the big idea here is, if you are dealing with a direction, if you're given a direction from previous in the problem or something like that, that's when you should incorporate the direction. Otherwise, just assume that what you're being given is speed. Okay, so then now in terms of units here are kind of interesting, and you've actually seen these already, but if you can imagine, velocity was, the units for those were like meters per second, and then we divide that by seconds again, and so mathematically, okay, this ends up being equals meters per second times, and then if we divide by a fraction, we multiply by the reciprocal, 1 over s, so we just get meters per second squared. And does that look familiar at all? Gravity ringing a bell? Yep. So meters per second squared are common, feet per second squared are also common units for acceleration. Okay. Otherwise, really, it's any position unit over time units squared. Okay, so big idea here is, if with acceleration, change in speed, change in velocity over change in time, and then if you're given an angle, report that. But now the only thing I want you to be aware of is that in different contexts, we could have acceleration, we could also have deceleration, which is slowing down, right? So this would be an instance where maybe you're initially going like 50 miles per hour, and then you slow it to like 30. Okay, so that's an instance where you can get, so this can be a negative, you can have a negative in your acceleration. Okay. Now, the other thing to keep in mind of is that you can have negative acceleration, but it truly is accelerating. So this would be the instance where you have to keep in mind direction. Okay, so imagine like if you're, starting at city center, and then you're stopped, and then you are driving due west at like 30 miles, or you start and then you get up to 30 miles per hour. Okay, so this would be a negative acceleration, so it'd be negative 30 miles per hour squared or something like that for your acceleration, but it's only negative because you're going in the negative direction. Okay, so something to be mindful of, and we'll get some more practice with this in class. But for now, let's go on and do a couple examples. So I want you to pause the videos and see if you can do these on your own, and then I'm going to write out the solutions and then explain them. And here are the solutions that I have. So this first one, change in speed was going from 55 to 0, from 0 to 55, so you started at 0, ended up at 55, and did 3 seconds. So you got this, and then I noticed something really, really awkward. So the units on this, 55 would be in miles per hour, and then 3 would be in seconds. So I ended up with miles per hour seconds, and that's mixed time units, so that's really weird and awkward. So I just converted seconds into hours. So I converted this seconds into hours, and so I got 66,000 miles per hour squared. Okay, and that would be the average acceleration I experienced. Okay, the next one, is a little nuanced. So if you draw a little diagram, you have a bird driving, or bird flying rather, 20 miles per hour due south, okay, and then suddenly it turns and goes southwest, and so it's going at 20 and then it accelerates up to 30, so the difference is 10 in its speed or velocity. This one's velocity because, so these are velocities because we have direction. Velocity, okay, and 3 seconds, okay, so then again, we do the math, we get 3.3 miles per hour seconds. Seconds is awkward with hours, so convert one of them. I chose to convert seconds to hours, and so if I did that, I got 12,000 miles per hour squared. And then I also have to specify a direction, so if you can imagine, this is the 0 mark, and then you go all the way around here, that would be 225 degrees, or thereabouts. Okay, so this is in a sample of an instance where acceleration can be computed both using change in speed, and then this one is change in velocity. Okay, so be on the lookout for directions, and those are going to indicate to you that you need to use velocity. Okay, otherwise, here's a quiz question that I want you to think about and try on your own.